Okay, so what is the topic for today? So we're going to talk about working with really big or really small numbers. And so what I did before the lesson is I wrote down a really big number. And this number is the speed, or is the distance that light travels in a second. So light travels 300 million meters per second. Okay, so that's a really, really big number. And I also wrote down a really, really small number. So a really, really small number is this one over here. And this is, I don't even know how to say it, but it's basically, this is how wide a strand of DNA is. Okay, so you can just see all those zeros, 0.000000002. So this is a really small number, and this is a very big number. And if you are a scientist, so if you're an astronomer, I guess you have to deal with this really big number a lot. And if you were a biologist or studying viruses like the COVID virus, you would have to think about numbers of this size. And I want to start by asking you, what do you think it would be easy to work with these numbers, or do you think it would be hard, and why? Like, I'd love some thoughts in the chat. Like, if you had to work with these numbers every day, would you find it easy or would you find it hard? Let's start with that. Because I don't have to deal with these numbers every day, but if I did, something would strike me as being a bit difficult, I think. Would anybody agree with me on that? Maybe pop your hand up if you want to give us a little bit of input. Like, what would be difficult about dealing with these numbers?
Let's go, my people. We can do it.
Like, because we want to think about the main focus for today is how do we talk about or work with really big or really small numbers? So Tando has said there are a lot of zeros. I agree. It feels like in both these things, right? If I look at this first one here, like, look at all those zeros over here. It looks like there's 8 zeros over there. And it feels like it takes up a lot of space. Who else can see something about this? Sanaliso has also said it'd be hard because of the zeros would confuse you. Yeah, like if you had to say, multiply this number, well, I suppose 2 would be easy, but if you had to multiply this or work within calculated, all the zeros would kind of get in the way. And the same sort of thing would probably happen with the small number as well. It's just that the zeros come after the decimal place. So something I want to point out before we start is that the decimal point in a normal number, we don't write it, but it's actually going to be at the end here. And whereas in the smaller number, the decimal point is much more towards the beginning. So I would like to ask you, have you seen anything this year that you learned about that helps you write or deal with really big or really small numbers? Okay, Kanyesile, I'm good. I saw your hand go up. Can we unmute Kanyesile?
Okay, I'm still tracking Kanyesile because Kanyesile, I cannot see your hand up.
Okay, so I think, well, scientific notation, yes. Okay, so there is a topic called scientific notation. And what scientific notation does is it allows us to deal with, let me get my pen's being a bit wonky. It allows us to deal with really big or really small numbers in an efficient way. So basically it says, look at all these zeros. We need a way of writing this big number or the small number in a better way, but still for it to mean the same thing. So if you've had some experiences with scientific notation this year, give me a thumbs up in the chat. If you've never heard of scientific notation, give me a thumbs down. I just want to see if anybody's heard of it, and some of you have, some of you haven't. Just pop your hand up or down in the chat. Okay, so most students have heard of this idea of scientific notation. Some students haven't, I'm seeing. Let's make sure that we all vote on this because it'll be very helpful for us to, very helpful for me to know for the rest of the lesson. But I want to stay with the main idea that lots of zeros in a number make it very difficult to write. So that's what I want to start with. If only we had a way of dealing with all, or representing all the zeros without having to write them all out. Okay, so Yolanda, what I'm seeing is quite a mixture in the group. So some students, some of them haven't. And so we're really going to start at pretty much the very beginning, staying with the idea of how do we write very big or very small numbers. Okay, well, let me show you one quick trick. If I gave you these three questions, and we were trying to multiply out, I want you to put the answer. What is the answer to this question in the chat? So I want you guys to look at that. No calculators at all. All I want is you to write the answer using your own brain power.
We can do this, my people. Let's go. Likuwe, I see you. I see you over there on the chat.
So what is 3.45 times 100? So I see quite a few people are getting 300. Oh, that's way too thick. Let's go back to this one. Quite a few people are getting 345 for A, which I agree with. I would like you to now try and do B and C.
Sorry, Teacher Peter. So on the chat, there was some mixture of answers. I'm assuming that they don't really know how to get to 3.
Okay. So think about this. One of the interesting things is in our number system, each number is basically, if you look at the 4 and the 5 and the 3, each jump across, it represents one multiplication of 10. Now, if you think of 100, 100 is just 10 times 10. And so what the students who were doing this were doing is they were saying, look, if I times it by 10, I would move the decimal point to here. If I times it by 100, I have to move it 2 places. And so what happens is when you get the decimal point or the decimal comma here, you end up with 345.0 or 345. So one of the key ideas we need to master is we need to master when we times by a power of 10, and in this case it was 100, which was 10 times 10, we just move the decimal point across by that many places. So taking that idea, I hope that that was helpful. Let's try and do B now. So I want everyone to put the answer for B in the chat.
Those one of you that you got it wrong, please do the correction. And if you still don't understand, either you can raise your hand while others are busy with B and C, or you can ask on the charts.
And for those who are feeling comfortable with this, you can try and do C as well, but put C in the chat there. So I think timesing by 10, it's just going to mean, so basically another thing to look out for is if I'm moving the decimal point, if I'm moving it to the right, the number is going to get bigger. So because I'm timesing this by 10, I know I have to move to the right, and I move by 1 place, so I get 34.5. So notice I'm using a decimal point instead of a decimal comma, but it depends if you're in the UK or the US. But basically that when I move it 1 step to the right, it's gone up, it's 10 times bigger, and so I get 34.5. Now, in the third one, it's a little bit tricky because if I'm timesing by 1,000, well, what is 1,000? 1,000 is just 10 times 10 times 10. So what are we going to get for C? I want to know in the chat, what do we get for C? Now, I know the number is going to get bigger, so I'm going to moving it to the right. So that's 1 decimal place, and that's a 2nd decimal place. But now I've run out of things to jump. And what you'll realize is that you can always add an extra 0 here. And so if I jump over that, this is going to be equal to 3,450. You can say 0.0. And basically, if you imagine going backwards now, and I don't want you to go backwards, but you can see you started 1, 2, 3. You started over here. So one of the things that when we deal with scientific notation, we have to realize, or we have to be able to take, when we multiply by powers of 10, we need to be comfortable moving the decimal place to the right or to the left in order to allow us to multiply by powers of 10. Okay, so I'm going to do another round of these just to make sure that we are all feeling comfortable. And then while we're doing these, I'm going to ask students who are struggling to maybe come online and have a little conversation. But for the rest of us, what you're going to do for me now is you are going to do D, E, and F. Now you're not using your calculators, and all you need to do is find me the value of this calculation and this one and this one, but you may not use your calculators. However, if you are feeling very stuck, I would love for you to raise your hand or to pop a message in the chat, and we can talk a little bit about how is this decimal point moving around and stuff like that.
Let's go, my people. And Teacher Peter, can they also answer if they raise their hand and they're done, if they can answer D?
We can. We'll give them about another minute before we do that, but yeah, we can definitely have input.
Thank you.
Aganati, okay. If you look at D, the first thing to realize is you're multiplying by 10 squared. Now, that is just another way of saying 100. Now, in the previous question, when we multiplied by a number, we knew it had to get bigger. And so I'm going to suggest this decimal point is going to be moving in this direction to the right. The question is, how much does it need to move to the right? Is it going to be 1 hop? Is it going to be 2 hops? And what I want to suggest is that the power of 2 here, this 10 to the 2 just means 10 times 10. For each multiplication of 10, I have to hop 1 hop. And so I'm going to hop twice here. And so the answer for D is going to be 234.0. Now, I'm just using the decimal point, not the decimal comma there, but essentially it went from being behind the 2 to behind the 4. So for D, we should get 234. Now, what I want to see is, did that help? And can we do E and F? If somebody has a question, raise your hand and we would love to chat with you. Otherwise, keep those answers coming. So,
are you sorted, girl? You can raise your hand.
Okay. I see Kendra's answer for E, and she has said 23.4. And you know what, Kendra? I agree with you, because if I'm multiplying by 110 over here, oh, my graphics tablet is being a bit weird. Let me plug it in. If I'm multiplying by one multiplication of 10, all that's going to happen, there it is, sorry guys, this decimal point is just going to move 1 unit to the right, and I'm going to get 23.4. Who would like to help me do F? I'd love a volunteer to come online and just help me out with F, because it's a little bit more sneaky. Otherwise, I will go and look at the answers there. Bulela, I think I agree with you. I'll have to work it out still. So I love how they're saying times 10 to the power of 3. So that's something else which I want to point out, is that 10 to the power of 3 just means times 10 times 10 times 10. Oh, I think it's being weird. So I think I've got to move this comma 3 places. So 1, 2, and then I make a little 0 for it to jump over. And so I get 2,340. I'll put 0.0 just to make sure we know where it is there. Okay, in the chat, I want to see, all I've been doing so far is I'm taking numbers and I'm multiplying them by powers of 10, and then I'm moving the decimal point around to match that multiplication. I want to see in the chat, if you are feeling okay, thumbs up. If you're not feeling so good, thumbs down. I want to see in the chat how we feeling.
Hey, you guys are awesome. We're doing this. Well
This
done.
here is the foundation of how we deal with scientific notation. I promise you, we're going to get rid of the zeros, guys. There's going to be no zeros. When we see big numbers, we're using a different way. Okay. So here's a little bit of a sneaky one, but I think you can do it. What if, well, let's all do G and H together first. So everyone, I want you to multiply. What is 10 to the 4 times 10 to the 2? What's 10 to the 0 times 10 to the 6? So do those two, and then we'll talk about I all together. Over to you guys.
Let's do this, guys. Remember, don't fall into the traps. These questions have so many traps, guys. Don't fall for them. Let's do this.
There we go.
I see my people working really hard. You're focusing.
So remember, no calculators here, huh? So some of you may remember that 10 to the 4 just means 10 multiplied by itself 4 times, and the same with that. And there's actually a rule of exponents that helps you with that. But I want to know, what is that equal to written in the form 10 to the power of something? So I don't want it to be written with lots of zeros. I want it to be written with a power here. And the same thing for the next one. So we're writing this, admittedly quite a big number, but we're writing it where it's 10 to the power of something. And in the chat, if you want to do power of, we just use a little cuppy like that. So this would mean like 2 to the power of 3, if you wrote it in the chat. Okay, I see Tando has got an answer. Who else has got an answer?
Lela, Jabu.
Yes, keep them coming, guys. Okay, everyone seems to be 10 to the power of 6. So you're quite right. Basically, 10 to the power of 4 gives you the 4 tens. 10 to the power of 2 gives you that. So in total, you've got 10 to the power of 6. Now, if you wrote this out as a normal number, that would just be, because essentially you would have that, right? 1 million. But it's so much easier to write 1 million as 10 to the power of 6 instead of just all this over here. So I want to just point that out because it's kind of showing us a sneaky way on how to simplify things. Now, what about H? 10 to the power of 0 times 10 to the power of 6. Well, anything to the power of 0 is actually 1. So this thing is going to be 1. And so 1 times 10 to the power of 6 is still going to be 10 to the power of 6. Or for those of you who know the exponent law, if you multiply together two things that have the same base, you just add the powers. And so you should get 10 to the 6. So watch out for that, guys. I think the easiest way for you to see it, 10 to the power of 0 is 1, and 1 times anything just stays the same. And so the second one is also going to be 10 to the power of 6. Oh, something happened there. I don't know what. I'll come back now. There we go. Am I still sharing, or are you just seeing a whole lot of me?
We can still see the screen. That's okay. We still
okay.
see.
Every now and again, things go a bit wonky. Okay, let's do I. So what is 3.4 times 10 to the power of 5? Now we are taking it up a notch. And just remember what we did earlier. How did we move the decimal point in order to do a multiplication by a power of 10? So I want everyone to try their best to do 3.4 times 10 to the power of 5. See if you can do that for me.
We can do this, guys. At least the last few had some sneaky things on it, but this one, we should be able to nail it.
If we can do this one, we're pretty much, a lot of the scientific notation stuff is done. Where did my... I see some answers coming in.
Mhm.
I was thinking I need to, if I jump over the first one, I know it's timesing by 10, I'm going to get bigger, but now how many more jumps do I need to do? I think I need to jump, I need 4 more because I jump over the first one. So I was at 3, I was here and I went to there. And then I just needed to make sure I had enough to jump over everything else. So for me, what I get is I get 340,000. Okay, so have a look at that and see if you agree with me. I jumped over the 4 for my first jump. So basically I got to, let's see here, I got to here. But then I need, because I multiplied by 10 to the 5, or I multiplied by 10 times 10 times 10 times 10 times 10, I had to jump 5 times. So I went 1, 2, 3, 4, 5. And that basically my final answer is that 340,000.0. Okay. So that is a basic question I. We would say that question I is written in scientific notation. Now, in scientific notation, we have like a number part in front, and then we have a second part where there's a times 10 to the power of something. Over here, this is called ordinary notation. And can you see how in ordinary notation, we have so many more zeros? And so that's why we need to feel comfortable learning how to change between these two forms. Are there any questions, or Yolanda, anything that you noticed? That's...
If we can please zoom a little bit out. Okay, out.
Out?
Zooming out, yeah, so we can see all the 3 questions. Like this, they can take screenshots.
Okay.
Let's do this, guys, and then you can do corrections. Okay.
Okay, so what we have there is we are now going to try and get more comfortable going between these big numbers or small numbers and writing them in what we call scientific notation. But I want to actually show you how that works now. So take a screenshot if you need to, and then we're going to move to this. Okay. So what does it mean to write something in scientific notation? You guys are going to love this. So remember early in the lesson, I said to you, sometimes you have to deal with really big numbers like this. And you have to, it would be so much nicer if we could write them in a simpler form. So what I'm going to say with this number is at the moment, the decimal point is here, and I'll even add on a little 0.0. And this number to me looks like 367 million. Okay, it's because I see the 6 zeros. If I want to write this in scientific notation, all I'm going to do is I'm going to say, oh, I'm going to count. If only I could get my decimal point from here all the way to here where it only has one number in front of it. And I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So what I now do is I'm doing the opposite of what I did before. I write down that number, 3.67. And then you stop and you think, oh my goodness, I must have made a mistake because I started off with 367 million and now I have 3.67, which is tiny. So how can these be equal? And the answer is they're not equal. I've left off a really big part. But the really big part is the times 10 part. And how many, what is the power going to be? I want to ask in the chat, what is the power going to be that I need to write here? Now think about how many hops I did. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8. And so we say 367 million written in scientific notation is just 3.67 times 10 to the 8. And oh my goodness, that's so much quicker to write than all those zeros. And what we're using is this idea that each decimal point hop is basically multiplying by 10. Okay, I want you guys to do B for me. So I want you to write B in scientific notation for me. Over to you guys. Pop it in the chat there.
Let's go, guys. We can do this.
Okay, so I see some people are writing it in. Let's give it a moment or two more. I see lots of people know it's going to be 2.19. I suppose that's the simple part. The question is what goes with that. So I have my decimal point down here. 1, 2, 3, 6, 7. I think I saw. So look at the number. 2.19 is way smaller. So if I stop there, unfortunately, guys, I got it wrong. But I know this extra little bit is going to be basically a number of times I multiply by 10. And how many times do I need to multiply by 10? 7 times, or 10 to the power of 7. Okay. How is everyone feeling at this stage? Can we do 2 more before the break? Give me a thumbs up if you think we can squeeze in 2 more before the break. Okay. Tell me what these 2 numbers are, or let me leave that up there. What are those 2 numbers written in scientific notation? Yes. Me.
I'm actually on the line.
Okay, let's try and do C and D, and then we'll have a break.
Teacher Pete, Amakle is on the line.
Oh, Amakle, yes.
Yeah.
Can you unmute her? I've lost my too many things on the screen.
Hi, Amakle.
Sorry, I wanted to ask a question for B.
Yes.
Would it not be 21.9?
Okay. Whenever we have scientific notation, Amakle, we only leave one number in front of the decimal point. If we had left 21.9, we should have actually taken another power of 10 out of that 21. So you can write like 21.9 can be written as 2.19 times 10. And so that extra times 10 should have gone into the tens at the end. Does that make sense?
Yes.
So the number in front must always be between 0 and 9.99. So basically this part must always be a number less than 10, because if it was bigger than 10, that 10 belongs at the end with all the other 10s.
Oh, okay.
Does that make
Thank
sense?
you, sir.
Cool.
Yes, sir.
Right. Oh, my computer is being so badly behaved today. It just keeps on sliding off screen for some reason. Although I don't think you guys can see it, but I get the shock of my life when it happens.
Teacher Peter, we cannot see that. But Tando is asking, how do you know where to end? So Tando, I'm not quite sure, or maybe Teacher Peter will understand quite your question, but I'm not quite sure what Tando is.
Okay, let's start with this, Tando. First of all, where is the decimal point? In this really big number, it's all the way over here on the right. And so what we're going to do is we end when we have one number between basically 0 and 10 in front of the decimal point. So I'm going to keep going. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to stop there because if I hopped over this, then I've gone too far. We always need to have that one significant figure in front of us. And so that is where I'm going to go stop there. Now, if I write it like that, I'm just not telling the truth because 6 is way smaller than the number I started with, and there's an equal sign. So I'm just going to count again. So 9, 10, 11. So we would just say 6 times 10 to the power of 11. And that would be my answer. And for D, it's a little bit simpler. So even numbers that aren't that huge, that's at that point, I go 1, 2. So I go 1.78 times 10 to the power of 2, or basically it would be times 100. So 1.78 times 100 will give me that, but I've written this in scientific notation now. So you have to pass all the zeros, yes, and you have to get left with only one number in front between 0 and 10. Okay. Give us a thumbs up if you're feeling okay. Give us a thumbs down if you're feeling like, bleh. Okay.
Let's go.
I think it's time for a stretching break. So, Yolanda, I think if you could please tell me which students are the best stretchers. I'm going to stretch. And then after we've had our stretch, I'm going to put a little brain teaser thing on. But first, I want to see who is.
Guys,
that's good.
do this. Roberto, is that like in between?
Pamela, what we're doing is we're stretching now. So this, for those who are new, this is called our stretching break. And we know we need to send blood to our brains. Oh.
Yeah, I see Kendra. Kendra, you're winning today. You're winning. Eminati, let's stretch. Let's go. Do some stretching skills over there. Lawrence, I can't see a stretch. Woo, look, I go with you, girl. Yes, we're doing it.
Okay, so I highly recommend the stretches, and we know they help us. We're not meant to sit in our chairs forever. Before we move on in the lesson, let's see this brain break. So let's see. I want to know what a monkey minus an angry bird times a bee. Okay, Tumelo, hang in there. Don't worry, we're not done with scientific notation yet. We're going to keep on going. Okay. Okay, so I want you to try and work out this puzzle where you get, for me, the final answer is going to be this part over here. Let's do it.
Let's exercise those brains.
Yeah. Notice also there are three monkeys. There are three monkeys in this over here. Okay, so Tando feels like, and Princess also feels like they've got the yellow bird. Let's keep swimming and try and get the final one there.
Let's go, guys.
Okay. So what we're getting is a lot of people are saying that, and I agree with them, the only number that will give me that one is going to be 4. But now what are the B's going to be, if you excuse my... So I don't think a B would be 4. I think basically what number times 4 gives you 36 is one of the hints I can give you. And then that has to be broken up into 2 factors. Yes, I think this is going to be, a B is going to be 3.
Ooh, let's go, guys. So Anganati, this is just like a brain break that we do. We solve like puzzles for your brain to exercise all of these things. So don't worry much about it. You will.
Yeah, if you're new to this, don't worry. We do one every week, and you kind of start to get the structure after a while. But basically, solving for these unknowns. Now, the next problem we have, and I suppose the tip I can give you is to say, well, what is 3 times 4? It's 12. And then we need to ask ourselves, well, 12 times what gives us 72? So 12, you're quite right, it's 6. But now the problem is that if this whole thing is 6, there are 3 monkeys here. There are 3 monkeys. So now what will each individual monkey be? Because there's only one lonely monkey sitting at the end there. Aha, yes. So I think each of these monkeys is going to be 2. So what will the final answer be? That is what I want to know. And you need to use some BODMAS. Which of these operations gets done first? The minusing or the multiplying? So Is it the 4 times 3 that gets done first, or the minusing that gets done first? So we have this situation. And I think that this has to get done first because BODMAS says multiplication comes first. So what's my final answer? I have 2 minus 12. And the final answer is, yes, it's going to be minus 10. Because remember, 2 minus 12 is minus 10. So for any newcomers, if that was a little bit like, whoa, don't worry, the format stays the same. And that was actually a little bit of a trickier one. And we like to just mix it up a little bit in our lessons just to keep us on our toes. So if you want to take a screenshot, do that now. Otherwise, the answer is minus 10. Where were we? Okay, so I want you guys to write these 3 numbers in scientific notation. Okay, so 1.1 to 1.3. I've given you 3 questions. I want you to write them in scientific notation. They are all fairly large numbers. And so over to you guys. Think about what you've learned. And if you are feeling a bit lost, there were some students who were saying that they feel a bit unsure. If you raise your hand, we can have a chat or pop something in the messages, but we'd love to have a chat with you. So pop your hand up and we can discuss like where you're getting lost in 1.1.
Yeah, because guys, and well done to all of you. Remember, some of you are doing this for the first time. So you will definitely understand after the session, after the lesson, and also remember that this will be uploaded after 24 hours. So you can rewatch it again. So definitely you'll understand it for your exams.
I mean, the main goal today is just to realize if you've got really big numbers, sometimes they can be written in a different way. And we're just getting comfortable with that different way of writing it. That's our goal. So if you want to write something as a power, like if you want to write 10 to the power of 4, in the chat, you can just write it like that. So you could write, if you wrote 2 times 10 to the power of 4, it would look like that. So for the first one, I'm going to find my decimal point, which is over there. In this one, the decimal point is over there. And in this one, the decimal point is over there.
My people on fire. Let's keep coming, guys. And remember to correct, okay? Once Teacher Peter has corrected us, please make sure that you mark your work.
Yeah. So I see some students are rounding off. It's not wrong to do that. So that's sort of a separate issue. But for now, I'm going to write the whole thing out. But you, in theory, can round off that first one, depending on the instructions. So in this one, we know that that first number is going to be 3.728935, but that's still way too small. And so what we have is we need to write the part that goes times 10. And how many jumps? 1, 2, 3, 4, 5, 6. So times 10 to the 6. Now, if they say, well, you can also, if you want to round it off to 1 decimal place, then what you do is you ask yourself, well, can't we round this off? And if we did that, that would just be 3.7 times 10 to the 6. But for now, I'm going to stay with the full answer. We'll deal with the rounding off at a later stage. But it's not wrong to write 3.7 times 10 to the 6. Most of the time, it would be like that, I guess. Okay, what about 1.2? I'll wait a little bit of time for 1.2 and 1.3. Yeah, I see. As you kind of get a feel for these dots and how they move, you start to feel like there's a pattern here. Yeah.
Definitely. Let's go, guys. Let's do this. 2 questions to go.
Yeah. So 1.73. So this went 2 hops. I'll put 529 times 10 to the power of 2. And then what is the last one going to be? Let's see how many. 1, 2, 6, 7. I think I got 7 jumps there. Okay. So what is the number going to be? So we go 8.75. That would get us all the way to one number there. And then 1, 2, 3, 6, 7 times 10 to the 7. Okay. So these are going to be our 3 answers written in scientific notation. Now, I want to point out something to you. In scientific notation, there is always a part at the end which has times 10 to the power of something. Okay, so that is, whenever you've got it written in scientific notation, that has to be there. The other bit I want to point out is that the number in front of the decimal point, there's always only going to be one number. And that number is going to be between basically 0, well, it's going to be between like 1 or 0 and 9. However, sometimes you do have a choice to have these decimal figures after that, or you can round them off. At the moment, we're just leaving everything there. But if you had to round that part off, you could round it off to 1 decimal place, 2 decimal places, 3, just depends on the question. Okay. Are there any comments or questions? Are we okay to do one more round of this? Give us a thumbs up if you're ready for one more round of this. Okay. I'm going to give you a little preview of the next lesson. So if we look at these, we're going to do 1.7 is going to be the final question. We're going to dodge these ones over here. But before we dodge them, why do you think I'm dodging questions 1.4 to 1.6? I'd love someone to put in the chat or yeah, just give me some indication. Why am I choosing to leave these ones out for now and only do 1.7? What's my thinking? Well, the decimal point, yes, but look at the numbers themselves. If you look at like 1.4 to 1.6, look at the size of the numbers and look at the size of 1.7. What would you say about numbers 1.4 to 1.6 versus 1.7? I would say 1.4 to 1.6 are all really small numbers, and whereas 1.7 is quite a big number. And so when we deal with scientific notation, yes, the zeros are first. You're quite right, Theo. So over here, these questions all start with lots of zeros. And what that tells us is it's a really small number. And when we deal with really small numbers, the format for dealing with them is a little bit different. And so I'm going to teach you about that in the next lesson. So we're going to finish this lesson off with just doing 1.7. So can you write 1.7 in scientific notation? Have we done 1.7 already? I don't think so. No, we haven't yet. So let's finish up with 1.7. And then Yolanda, if we could just get ready with the poll once we've done 1.7. Okay.
Perfect.
So let's see in the class, what's the answers for 1.7? I see Jabu's got an answer. So the decimal point is over here. 5, 6, 7, 8. So it looks to me like there's 8. So I know I'm going to get 3.45. I know I need to have it times 10 to the power of something. And so this is going to be to the power of 8. So that should be our final answer. Okay, so what did we learn today? We learned how to take really big numbers and write them in a different type of notation called scientific notation, where basically we have to just keep track of where the decimal point is. And if we move the decimal point all the way to the left with just one number in front, we have this extra bit that we add on, but it basically allows the number to be written in a much more efficient, quicker way. And that's it. Okay, if you could just pop the poll for the students, and then, yeah, let us know how it went today, how it felt. It really helps us to keep track of what the ideal pacing is for the group if you are involved with the poll.